Welcome to EDU-VALUED Academy, where education is evaluated. In my last class, I discussed about congruence and similarity. I've also told you about the Thales theorem, and I proved it. And with the help of Thales theorem, we have come to the properties of similar triangles. That is the reason we know Thales theorem is known as basic proportional theorem, because he was the man who told us about the division and multiplication in algebra. So please do follow my video throughout the class, so that you will come to know about the property of similarity. We have come to know similarity. We have only one similarity as respect to angles, at least two angles of a triangle. If two angles of a triangle are equal to the two angles of another triangle, then those two triangles are similar and their corresponding parts are proportional. Proportional means they are in ratio, that is giving us the notion of division in geometry. Here, ABC and M and R, these two are similar. This is the notation of similarity. That's what I told you. If angle B is equal to angle M and angle A is equal to angle N, then these two triangles are similar. We need not show three angles of a triangle, because we know some of the angles of a triangle is 180 degree. So definitely, if two angles of a triangle are equal to two angles of another triangle, then definitely the third angle will be automatically equal. Then they will be similar. They will be alike. As we know, their angles are equal, their corresponding angles are equal. Here, corresponding parts of similar triangles are proportional. What does it mean? It means the ratio between the sides opposite to equal angles are equal. That means if B angle is equal to M, then side opposite to angle B is AC and this is NR. That means the AC upon NR is equal to, this is BC and side opposite to this angle is MR, is equal to BC upon MR, and this one third angle opposite to third angle is AB, opposite to third angle is MR. So AB upon M. Therefore, this is we have. That means the sides opposite to the equal angles are in the same ratio. That is what we say proportional. That's what we have. Now I will discuss and explain briefly about the Pythagoras Theorem. Pythagoras Theorem, the famous theorem to find the length with the help of geometry in right angle triangle. His statement is that we know well, hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is the largest side of a right angle triangle. So the statement is that this the square of the largest side of a right angle triangle is the sum of squares of the other two sides. But we say the square of the largest side is hypotenuse, that is hypotenuse square, is equal to the sum of the squares of other two sides, that is perpendicular square plus base square. So here we have a triangle BABC in which the angle A, that means angle BAC, is 90 degree. That's what it is written given. In triangle ABC, angle BAC is 90 degree. To prove largest side, the largest angle is 90 degree in this triangle. That's what I told you in my basic geometry part 2. The opposite to this is largest side, BC. So BC square is equal to AB square plus AC square. That's what we have to prove. Here we have three triangles: triangle ABD, triangle ACD, and triangle ABC. Two are smaller as compared to ABC, and one is ABC itself, in which there are two triangles ABD and ACD. These are smaller triangles. Here we will choose one smaller one and the triangle in which the smaller one is belonging to. You see, ABC is a triangle and ABD is also a triangle, but ABD is a triangle inside triangle ABC. So here angle B is common to both triangle ABD or ADB and ABC, that is in triangle CAB. So I've taken in triangle ADB, the smaller one, and CAB, the greater one. Here ADB angle is 90 degree. So far as construction is concerned, I've already drawn a construction. AD is perpendicular to BC. BC is the hypotenuse on which I am drawing the perpendicular from the vertex of the right angle in triangle ABC. Here you have to consider this case. Angle A is 90 degree and angle ADB is also 90 degree. So one is each of 90 degree angle ADB and angle BAC. I told you already ABD and ABC both are common. So here ABD is equal to ABC, common. Therefore, angle triangle ADB and triangle CAB both are similar by AA similarity. By AA similarity. By AA similarity. You see, angle A matches with angle A, that means DAB matches with angle C, that is ACB. Angle D, here ADB, in triangle ADB, D is 90 degree and CAB, A is 90 degree. And B angle is common to both. But we will not consider the ratio opposite to angle B. In our previous class, we have come to know CLASS theorem, and from CLASS theorem we have derived the properties of similar triangles. That is the reason I told you CLASS theorem is known as basic proportional theorem, BPT. Here we will have proportionality because unless we multiply two similar quantities, we will not have squares. The squares is the product of multiplication, and multiplication and division is found in our ratio that is given by our famous CLASS. So here We will not consider the ratio between the sides of the common angle, that is angle B. Rest here by similarity, side opposite to angle this one 90 degree of the smaller one, that is AB here, and BC is the 90 degree of the greater one. So this is your 90 degree. Opposite to 90 degree is BC. So AB upon BC is equal to. Now we will consider the next third angle is this one, and third angle of this greater one is this one. So this is your BD. Angle opposite to BAD is your BD, here BD, and this is equal to this angle of the greater one. This is C. Opposite to C is AB, this is AB. So cross multiply. AB square is equal to BC into BD. This is the number 1. What we have considered here, a smaller one and the greater one. Again, we will go with the same concept. This angle is 90 degree of the smaller one, and this is 90 degree, and this angle is common to both the triangle ACD and also ACB. So similarly, these two triangles, triangle ADC and triangle PAC, these two triangles are similar. Why? Because A angle matches with the B, A angle matches with B. Angle A means in this triangle ADC, angle A is here, so that is DSC, and this is equal to angle B. Now you see angle D is equal to angle A, so here we have written D is at the place of D, we have replaced A. So this way ADC is similar to BSC. Now again we will not take the ratio between the sides of the equal angles, that is the common angle, that is C. So next again opposite to 90 degree is AC, and opposite to the 90 degree is your BC. This is your common, leave it. This opposite to this is DC, and this is equal to this one, so this is AC. So AC square is equal to BC to DC. Second equation we have. What we have considered here, one smaller, one the greatest one, in which the smaller one is there. So we have common angle, we have right angle, because we have already constructed one perpendicular, and that is the reason these three triangles here are all right angle triangles. The right angle is common, and the smaller triangles are just sharing one angle, that is common. So now adding, so from 1 and 2 we have AB square plus AC square is equal to AB square means BD into BC, and AC square is equal to DC into BC. Now you see here BC is common. BC is common to both. I have taken common BC. So this is BD and this is DC. So BD plus DC. And from the figure, BD plus DC is BC. So from figure. So BC into BC is again BC square. So AB square plus AC square is equal to BC square. This is the proof of Pythagoras theorem. I think you have got it. You just construct a perpendicular from the vertex of 90 degree to the hypotenuse, and then we will have three triangles. Out of them we will choose one smaller one, one greater one, one smaller one, greater one, and there we will just have two equal angles, that is one common angle and one is 90 degree, and then we will not consider the ratio of the common angles. If you understood, like it, share it to your friends, and do subscribe my channel. Thank you.